Hi, and welcome to Physics 2212 Lab 1, Charge Tapes. We will start with an introduction of the experiment, followed by key models used. Then we will do an overview of the experiment and the code model used, and lastly, the discussion and conclusion. An introduction to the lab. The purpose was to use clear tape to observe the transfer of electrons between surfaces and to approximate the charge and number of electrons transferred. Fundamental principles include Newton's second law, force equals mass times acceleration, Coulomb's law, force equals K, a constant, times charge 2 times charge 1 divided by r squared, with r being the distance between the two charges. Note that this only applies to point charges. And lastly, I used dimensions of an atom to calculate the number of excess/deficient electrons per atom on a charged tape. A preview of the results. Charged tapes attracted neutral objects. The charged tapes repelled each other. The tapes were determined to have a positive charge via the Penn test, discussed later. Charge on each tape was 8.4 times 10 to the negative 9th coulombs, and each tape lost around 5.25 times 10 to the 10th electrons. The model used here, each charged tape was modeled as a point charge with all of its charge concentrated at the center of the tape for the sake of simplicity. Therefore, Coulomb's law can be used to calculate its charge. The two key assumptions here are that each tape is treated as a point charge, and that each tape has equal charge, and that this charge is distributed equally across its surface. Now to look at the experiment. The system was identified to be tapes B and A, with the surroundings being anything else in the room. The initial conditions were two identical pieces of neutral tape with one end folded to create a handle, and two additional pieces of tape on the desk to use as base tapes. Tape B was pressed onto a base tape and ripped off quickly. It was then held up against various objects to observe its interactions and determine its charge. It was then hung loosely between two books and held against a similarly prepared tape A. The distance between the two tapes, once they started floating, was measured. Observations. The charged tape was attracted to neutral objects like my hand and my notebook. It was repelled by another charged tape, which leads to the assumption that they are equally charged, and it was attracted to a negatively charged plastic pen, meaning that these charged tapes were indeed positively charged, and therefore lost electrons. Some data and calculations. The mass was found to be 2 times 10 to the negative 4th kilograms. The tape length was 0.2 meters, and its width was 0.015 meters. The distance between the floating tapes was 0.018 meters, which was averaged over 3 trials. Force of gravity is mass times the constant g, equaling negative 1.96 times 10 to the negative 3rd newtons. The electric force, since the floating tape is not accelerating, the electric force is equal in magnitude and opposite in direction to the force of gravity. And lastly, charge was derived from Coulomb's law, pictured on the bottom left, and was calculated to be 8.4 times 10 to the negative 9th coulombs. Electrons lost was calculated by dividing the charge of the tape by the charge of a singular electron, meaning it lost around 5.25 times 10 to the 10th electrons. The area of the tape was its length times its width, yielding 0.003 meters squared. The area of an atom is just the length of an atom squared. The number of atoms found by dividing the tape area by the area of an atom, which was 3 times 10 to the 17th atoms. And lastly, the ratio was 1.75 times 10 to the negative 7th electrons lost per atom. Now to look at the glow script model. I defined all of the constants used in the equations already discussed. The code then prints out the charge, deficiency of electrons, and ratio. And then two spheres are modeled, with the orange one being tape B, the blue one being tape A, and two arrows, with the blue one being force of gravity and the orange one being electric force. Lastly, the code prints out that the electric force and force of gravity are indeed equal. Now for the discussion. Discrepancy between the model and real life. So these tapes are not actually point charges, they're simply modeled this way. And also the charges were likely not equal. It's very difficult simply by ripping these tapes to create exactly equal charges. Possible sources of error include unequal charges on each tape, lost charge when handling, as well as high humidity in my room. I have a device that tells me the humidity in my room, and it's currently 76%, which is very high. So what if electrons had positive charge and protons had negative charge? This would not change anything in the results of this experiment. It would mean that the tapes would be negatively charged, and when you charged a plastic pen, it would be positive, but they would still repel each other, and the results would still be the same. It's important to handle the tapes as little as possible, as when the tapes come in contact with your hand, they become neutralized. Thank you.